Okay, hi, I'm back. I'm just on my normal desktop or laptop, I guess, today. So, um, parent functions. Okay, so these are like the base functions, and then we manipulate them for different situations. So, should know these. When I was in high school, I'll admit I was really bad at memorizing, and well, I'm good at memorizing. I chose not to memorize because I didn't see a need. So when I say know these, if you can do them about 2 seconds or 3 seconds, I will count that as knowing them. So this guy's just constant function. So what it's saying is if you input whatever, that is your output, right? So if so like let's say the output, say you're getting paid $100 to do a job, it doesn't matter what your input is, your output's going to be 100. So that's going to be a constant function, right? If I work 10 hours, I get 100. If I work 20 hours, I get 100. Evidently, if I work 0 hours, I'm still going to get 100. So someone gave me 100 no matter what. I guess if I quit, I get to keep the 100. I don't know. All right, over here, this again is my input is X, okay, and my output is going to also be X. So here my input is say 3, my output's 100. But here my input, if my input's 3, my output's 3. If my input's 100, my output's 100. So this is kind of like Y equals, right? Like f of X is like Y equals. So if you have, y equals x, right? Okay, so if my input 0, my output 0, 1, 1, 2, 2, 3, 3, negatives, right? So it's going to be a line that goes through like that. Okay, this guy's a quadratic, so it's a parabola, goes through 0, 0. Now again, you should just know that. But if you have to do a tiny, so if you have to go, oh yeah, 1 squared is 1, 2 squared is 4, 3 squared is 9. Oh yeah, it's symmetrical. Those would be over here. Yeah, I can draw a good one, right? That takes just a couple seconds, right? Not a big deal. Okay, input is side length and area. And again, I know you can't have negative side lengths, but in math, you can have negative numbers. Absolute value function we talked about is very similar to this, except if you sub in 0, you get 0, 1, 1, 2, 2, 3, 3, right? So that is it's not curvy, right? But it goes there. But if I sub in negatives, I also get positives. So this guy looks like that. Okay. That's the absolute value function. And here you get, like, if it crosses a line, you get two answers. Same thing here, because distances, remember, you can go right or left. Okay. Square root function. Again, if you're like, I don't have it memorized, well, what's square? Can't have negatives. So what's square root of 0? 0. Square root of 1 is 1. Don't do 2 because it's ugly. Square root of 4 is 2. And then you're like, oh yeah, 9 would be. So this is a very slow function. Okay. I don't know. When I was younger, it reminded me of a turtle or, I don't know, a hump or something. All right. These guys, I definitely never memorized at all. So with 1 over x, again, if you want to make an input output just, again, to make you feel good about what you're doing, that's not a bad idea. So if you sub in 0, it's undefined. Okay. All right. So that's going to be an asymptote. We'll deal with that in a second. If you sub in 1, okay, 1 divided by 1 is 1. If you sub in 2, you get a half. So at 2, you're at a half. If you sub in a half, this guy's the reciprocal function. It's going to flip it. It's going to reciprocate it. So that's going to go up to 2. So you can kind of get a feel that that guy is going to go there. Okay, now, don't stop. You should check over here. With rational functions, there's usually like stuff here, 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 right? Any of those combos. So let's sub in some negative numbers. Well, -1, okay, reciprocal of a -1 is a -1. Sub in -2, right? That would be, so at a -2, I would be what? -half. And at a -half, I would be at a -2. So you can see kind of there, going right there. And we have asymptotes here, and we have another asymptote here. So they're not going to ever cross, okay? So I can figure that guy out within a few seconds. It's okay. What about x cubed and cubed root of x? Same idea. Definitely when I was in high school, I'm like, yeah, I don't have space in my brain to memorize that. But again, if you understand input output, if you kind of know the general shape of it, that's helpful. This one you will probably know eventually. I always kind of think of it like a disco, right? It kind of goes here like John Travolta. So 0, 0, 1 cubed is 1. Now notice 2 cubed is 8. So it's going to get big really fast at that 2. So where am I at? 1, 2, 3, 4, 5, 6, 7, 8. So it's going up fast. And then so that's at what? 1 and 2. And then if I sub in, say, a -1, -1, -1, -1, that puts a -1. -2, -2 times -2 times -2. Notice that's at a -8. I'll just put a point here. So this guy is gonna, and again, try to get that bend in there. So, and I'm not super great, but we can look at Desmos in a second. So this I always kind of think as kind of a disco, you know, John Travolta, right? Dancing, okay? All right, so, and it has like a positive movement, like this is kind of positive disco shape, right? Okay. And then if you're like, well, then what's the cubed root? Again, you can make an input output chart as long as it doesn't take you, if this takes you half an hour, too slow, right? Cubed root of 0 is 0. Now, again, pick smart numbers. 1 is a good choice. Cubed root of 1 is 1. And then you're like, ooh, cubed root of 2 is bad. 3, 4, oh. And then you're like, oh, 8 would be a good choice. Cubed root of 8 is 2. So that's kind of going way out there. All right. So kind of, I don't know, sort of like that. All right. Now what's happening on this side? Cubed root of a -1 is that. And you're like, oh, okay. So then a good choice might be -8. You want to pick friendly numbers. Cubed root of that would be a -2. So way down here. So this guy is going to kind of, I don't know, kind of look like that. All right. And if you notice, you're like, wow, those look really similar. That's because they're inverse functions. Notice this passes a vertical line test. Great. Passes a horizontal line test. This is a one-to-one function. This guy is going to be its inverse, okay? And the way we do that, the way we find the inverse is we think about, we want our input to become output, output to become input. So I'm going to make that, I'm going to swap those guys. I'm going to call my output X, I'm going to call my input Y. And then I'm going to isolate an inverse. How do you get rid of cubing? You cube root. And then I'm going to call F inverse. And notice I get that guy, okay? All right, so the way you find the inverse is you swap your functions and do that. Now, the other two I did not memorize when I was in high school, which was just not a good choice. And when we get to trig, I'll explain, you know, how I know this. But your sine function, I would use a unit circle to figure it out. Let me just tell you, it looks like an S, okay? And then it obviously keeps going for infinity, right? But I didn't even memorize that. And that was kind of not very wise on my part. So it goes mid, high, mid, low, mid to start those key points, right? Okay, and it has a period 0. It does that from 0 to 2 pi, but we'll get to that when we do trig, but it makes an S shape, okay? And then the other function I should have memorized was cosine, but I didn't. I figured it out by subbing in points, but I was too slow, all right? This guy looks like a cup, okay? Cosine goes with cup, sine looks like an S. And this goes high, mid, low, mid, high. And again, goes off to infinity, right? So keeps going with that pattern. And again, does that from 0 to 2 pi. But I didn't memorize those. I should have, right? Okay, so just make sure you know the parent functions, right? So if I give you an absolute value where it's like, oh, it's x plus 3, you should at least know it is a V-shaped, right? You should know that. If it's quadratic, you should be like, oh, it's a parabola. It's going to look like one of those, right? If it's a square root function, you should be like, oh, it's here. Now, maybe it's reflected. That could be. That I don't know. But just know them. And then we're going to do a lab where we do some transformations on them so that you can kind of figure those out a little bit on your own. All right, I'm going to pause a little bit. We're going to do inverse functions in this video too. So I'm going to pause and we'll do those. Okay, I don't know how much time I'm going to be able to get inverse functions in, so because I'm cut off on 15 minutes on this one, but basically it undoes, an inverse undoes. So if I put a letter, write a letter, put it in an envelope, seal it, and mail it, the reverse of that, the inverse is I'd have to grab it out of the mail, take the stamp off, erase everything, open the envelope, take the letter out and erase it and get it back to where I started, okay? So here, if this is your one-to-one function, the inverse is gonna take the output and spit out the input. The function is going to have a totally different job. So this guy, you put in 1, maybe you put in a 1, you get the temperature in Iowa. You put the 4 in, you get the temperature somewhere else. 5, you get the temperature in Alaska. Here it's backwards, right? It's the inverse, it's the reverse, it's the undoing, okay? So here I'm giving you the temperature, you're telling me what state it's in. I'm giving you the temperature, you're telling me the state that it's in. I'm giving you the temperature, it's spitting out state 5, which might be Alaska, okay? All right, so your input and output swap. So that's why if you want to find an inverse of a function, you swap your input and output because it has a different job. Here I have input, what do? I multiply by 3, subtract 9. The reverse of that is going to have to be order of op in backwards order. So let's look at that. If I swap my x and y, this is my input now and my output goes there. Add 9. Again, how do we solve equations? We isolate an inverse. Now I want to inverse that. So divide by 3. And we usually rename it f inverse. And what is that? X plus 9 divided by 3. Now, that should not shock you. This function multiplies by 3 and then does what? Subtracts 9. So if, say I pick x equals 10, okay, what would it do? It would multiply by 3, which is 30, subtract 9, I get 21, okay? So when my input's 10, my output's 21. So for this function, it's, again, these are going to flip because I'm looking at the different things. So I'm giving you the 21, you're trying to find the input. So 21 plus 9, do you see how we're doing order of op backwards? 21 plus 9 is 30, divide by 3 is the 10. So this is the inverse function. It reverses the math for us. All right, let's look at this. I want to reverse this. Okay, so let's see. We're going to put our input there and our output here. All right, isolate the function first. Well, that's a big chunk. So add 8 to get rid of that. Okay, I still now want to isolate this function, get rid of the 3, so divide by 3. All right, this is a squaring function. To get rid of squaring function, I need to square root. And again, isolate an inverse is the name of the game. To get rid of subtracting 2, add 2. Now notice that's going to be outside of that other function. So you're going to get x plus 8 divided by 3 plus a 2, and I'm going to call all of this f inverse of x. All right, let's try to sub in and see what we get. Let's sub in 10 again. Maybe smaller. Let's make our life easy. How about that? Let's sub in 5. That might be a little nicer. 5 minus 2 is 3. 3 squared is 9. 27 minus 8. So if I take 27 minus 8, what is that? Is that 19, I think? Okay, let's do the math over here. So when my input was 5, my output was 19. All right, so if I come over here, now my input is going to be 19. So see what the math is. So we're doing kind of order of op backwards in a way. So 19 plus 8 is 27. 27 divided by 3 is 9. Square root of 9 is 3. 3 plus 2 is 5. And it undoes it for me. And it shouldn't surprise you. This has minus 2, subtract 2. This has adding 2. This has squaring. This has square rooting. This has minus 8. This has plus 8. This has multiply by 3. This has divide by 3. So that's your inverse function. You can do it on a graph too. Like if this is 0, 3, you know that the inverse function is going to be at 3, 0. And when you graph these, they're going to be symmetrical around y equals x. And I'll do that super quick on Desmos. All right, here's a graph on Desmos. Now, one thing you have to notice is a parabola is not one-to-one, okay? So what we do is we limit the domain. And so basically what we do is get rid of all of this part. We would say, yeah, x has to be greater than or equal to 2. So then what happens is it passes the vertical line test and the horizontal line test. And so then what happens is that then do you see how they reflect over y equals x? The two functions, the inverses, will reflect over y equals x, but we do have to limit the domain.